Fractional parts of numbers. Functional notation. Wow, I am getting smart.
Lesson 28 should still be part review of what you did in pre-algebra. So, again, I'm trying to try not to hit it too hard because hopefully you've heard it before, but maybe the way I explain it might be a little different. So here we go. There's two things we're going to do in this lesson. The first part is pretty kind of simple but fun, and it's fractional parts of numbers. And you would get something like this equation: 7/8 times 48 equals 42. Now this is written in basically the math language, mathematical language. We are going to translate it, because all math language can be translated into English. And so if I were to translate this, I would say, well, when we do 7/8 as English, we would do 7/8. Okay, that's how we say that in English. How we say this times, we're not going to say times. We're going to say of. Because of means times in English. 48. And yes, I want you to write this as well, just so you have it on your paper. Is equals, I'm going to write this. It equals is, and then we can write 42. So 7/8 of 48 is 42. 7/8 of 48 equals 42. So the reason we would do that is, I'm showing it backwards. Usually we're going to get an English sentence like this, and we're going to have to make that into an equation and find the answer. So we've got 3/4 of what number is 69. So what number is a variable? We're going to use a letter to represent that. So let's go ahead and make this as an equation. 3/4 times, I'm going to say n for number, equals 69. And there we have it. 3/4 times n equals 69. Now, as we did a little bit earlier, when we were solving equations, I'm looking back at what lesson it was in. I believe it was in lesson 26 or 25. We could also say 3/4 n equals 69. Now we want to get n by itself, so how do we get that? We're going to multiply this side by its reciprocal, because these guys now go away. But in order to make that legal, we're going to multiply that side by by 4/3 as well, so that we're balanced, so that we're still following the rules. And so these guys cancel out and just become 1n, or n. And this we can cross cancel. Again, if we want the training wheels, there's a little 1 under there, but I like to leave it off and just get used to knowing that these guys are diagonal. Alright, 3 goes into 69 23 times. And it goes into there itself. And then we're going to multiply 23 times 4. So it's alright to go off to the side and do that. And I see we get 92. So n equals 92. And that's how we solve it. So just to recap, we take an English sentence, turn it into an equation, and solve it. English equation, solve. Okay, let's try that with this one. What fraction of 40 is 24? So when you see what fraction we're talking about, that's our n, or our variable. You could say f for fraction. So f times 40 equals 24. Now if we were going to set this up like an equation you'd seen in the past, it would say 40f equals 24. And then we're going to divide both sides by 40, and I just ran out of room there. You probably did too. So you're going to have f, because those cancel out, equals 24/40, but we can reduce that. 8 goes into both of those. It goes in there 3/5. So f, the fraction, is 3/5. So that was the step again. Translate, solve the equation. Okay, let's do it here. Now when I have a mixed number, I always like to change that to an improper fraction. So if during the translation part, so this would be 5/2 times 240 equals n. So 5/2 times 240 equals n. There it is translated. Then we're going to go ahead and cross cancel because 2 goes into 240 120 times. So now we're doing 5 times 120. Now 5 times 12 is 60. So 5 times 120 is 600. And it's always good to go back and say, does that make sense? 2.5 of 240. So that basically means it's going to be a bigger number than 240. It's going to be twice and a half of it. So that's what we got there. And there we go. Now, totally switching gears, we're going to talk about something called function notation. It's using something you've already done and changing it up a little bit by writing it using a different notation. All that means is a different way to write it or show it. So we're going to be given the equation y equals x plus 2, and then I'm going to show it to you actually on this. Here it was y equals x plus 2, and I have it described here in this, make sure I'm focused here, in this grid. We maybe in the past called this a function machine because we are talking about functions. And what we say is, I'm going to write it up here, y equals x plus 2. Okay, what we say that y is a function of x, meaning y depends on, the answer here depends on what x is. So if we were to be asked about that, which you're not, this is just part of explaining why we're doing it this way, we would say y is a function of x. And I was actually looking to see where they said that in your book in case you wanted to read up on this. I'm looking at the bottom of page 117, and that's about functional notation. So if any of this is a little confusing, I recommend going back and looking at that and seeing if this makes any, if it helps to look at there, because this is a little different. So we say y is a function of x. So y, the answer here, depends on what x is. In fact, here we are. Y is x plus 2. So this is what the y values are. So we pick values for x. Let's say x is 5. Y is going to be 5 plus 2. So y is going to be 7. If x is 0, we plug it in. 0 plus 2, y is 2. If x is negative 75, and we add 2 to that, we're at negative 73. So y depended on what we made x. Alright, so that's that. Now let's throw something completely weird at you. Mathematicians use a different notation instead of using y sometimes. It's called functional notation, where instead of using the letter y, we say f of x. These can be interchangeable. You can replace this with this. In case you ever get confused, just be like, okay, when I see this, that's like saying y. Y equals. So if we said y is a function of x, we would say f is a function of x. Or what we say is, the way we read this, if I ever see this, I read to myself f of x. F of x. Now that might, not fox, f of x. So let's actually use this to see if it can help make sense. So let's take this for example. F of x equals x plus 7. We would say, like I just said, f of x equals, this is how we read this to someone, x plus 7. All right, so now they don't have f of x. They used a different letter, and that you're going to see a lot. You're going to see f, g. These are the big ones. The ones you'll see more often. But again, with letters, they can interchange them with different letters. Now, if we had this, again, this could have been y equals x squared minus 2. But instead, it's g of x equals x squared minus 2. This one is h of x equals 2x cubed minus 3. So that's how we read it. Now let's apply it, because some of your heads might be spinning. If you didn't do this last year, might be trying to understand what's the point. Well, I'm going to take two of the same problem. I want you to notice here in this example, we have the same basic equation. We have this x times the quantity x squared minus 3x and x times the quantity x squared minus 3x. Both same thing, but we're going to find the answer the same way. It just looks different. So it says evaluate this. Well, remember how I want you to use parentheses wherever you see a parenthesis or wherever you see a letter. So there's my empty parentheses, and I'm going to stick 2 in there. And then we evaluate, we calculate it. Okay, so the 2 is going to stay out there. I'm going to deal with what's in here. Now 2 squared is 4 minus 6. And then that's 2 times negative 2, negative 4. So if we evaluate, we get negative 4 as the answer. Now, we are virtually asking the same thing, different notation. I'm going to read it in English. If f of x equals x times x squared minus 3x, find f of 2. So what they're saying here is where there was an x, now put a 2 in there. So it says replace whatever the function was about with the number 2, which is what we did again. So we would say f of 2 equals. So we're just evaluating. The hard part is it's a different style. So again, just like we did on the last one, parentheses with the 2 in there, and then we, again, it's just like the same, it's the same up there. So again, it was like 2 times 4 minus 6, 2 times negative 2 equals negative 4. Okay, so how we would write that would be, you could just say negative 4, or you could say f of 2 equals negative 4. What that means is when I plugged in 2 for my x, I get a negative 4. Plug in 2, and we get negative 4. So 2 went in the function machine, and a negative 4 came out. Okay, notice again, we're going to show it 2 different ways. The old way that you did, and the new way. So again, parentheses, where we have a variable, and then plug in. Kind of wish I had more room so that maybe, I hope you can see my writing. So out here, negative 2 squared, that there's 2 of those, 2 negatives, so it's a positive 4. In here it's a negative 4 minus 1. Alright, we get negative 20. So when we evaluate this, we get negative 20. So we've done that before. This just looks different. It says where we see an x, put a negative 2. So we'd say g of negative 2 equals, and we put that just like we did above, just different notation. So I don't want this to scare anyone. We're doing what we've done, just it's written differently or said differently. So nothing changes here. So we could say g of negative 2 equals negative 20. Or just say the answer was negative 20. Okay, I believe that the next is practice. So go ahead and try these and then check your solutions and make sure that you're understanding this, please call or ask for help if you're getting stuck, especially on this stuff, which is a little bit new. But don't panic, okay? New does not mean scary. New just means new. So just relax, and yeah, you might not do it right the first time, and that's okay. So we're going to translate. So that's going to be 4/3 times n equals 64. And again, we're going to multiply by reciprocals on both sides. So that goes away and get n equals, now I know 64, actually 4 goes into 64 because 4 goes into 8 and 8 goes into 64. So how many times, you ask? Let's see, 16. So 4 goes into 64 16 times and itself once. So now 16 times 3, and that is 48. The next one, 3.5 times something equals 48. No, 3 1/5 times something is 48. So we would say 16 fifths times n equals 48. Then we're going to multiply by the reciprocal to get rid of it over there. Now isn't this nice? We just found out up here that 16 times 3 is 48. So it goes into itself once, goes in there 3 times, so n equals 15. And can we check this? Yes. How would we check it? We would go back and do 3 1/5 times 15 and make sure you get the right answer. I'm not going to do it right now, just in the interest of time. What fraction of 60 equals 48? So we would say n times 60 equals 48. And we're going to divide both sides by 60. So n is whatever this is reduced, 48 60th. 12 goes into both those. Goes in there 4/5. So n equals 4/5. Next one, 4.5 times 220 equals what? So that would be 9/2 times 220 equals n. And 2 goes into there 110 times, so 9 times 110. 9 times 11 is 99, so n equals 990. And now we have the different notation that we looked at. So I hope this didn't bother you too much. Let's try it. So f, we're going to find, I'm going to write it over here so we have more room. I'm going to look for the f of -1 equals, I'm going to plug it in. So -1 squared is a +1, -2. So f of -1 equals -2. This one would be g of 2 equals, and then plug it in. And so and we get 2. So g of 2 equals 2. And as I check in the book to make sure that I didn't lead you astray, we are correct. So enjoy that. Don't be scared and have fun. It is fun, you know. Don't forget.